Right, let's start. Today is the third class for the calculus class in summer. We learned about definition of derivative, okay? Last week, we used this formula to derive like those power rules. We found out that x to the power 1n derivative equals to n times x to the power of n minus 1. We will learn some very hard questions today. The power rule is easy. We will learn product rule and quotient rule and the chain rule today, okay? Let's take a look at the question. We derive those like x to the power 3. This guy, f prime x, we do limit h approach to 0, x plus h to the power 3 minus x to the power 3. If we open this formula, we get here. And then x to the power 3 can be canceled. This guy divided by h. When h approaches to 0, we can find out here. Now x to the power 4. This formula is not hard either. We can also do it. Let's take a look at fx equals to 1 over x. If 1 over x, then fx plus h will equals to 1 over x plus h. And then minus fx, which is 1 over x, divided by h. We can do the common denominator. X plus h times x is a common denominator. That becomes to x minus parenthesis x plus h. This can be canceled. Negative h is left. And then the denominator becomes to x times x plus h times h. And h canceled, so the result becomes to this. We always can make h to be 0, and this becomes to negative 1 over x squared. This becomes to negative x to the power of negative 2. So this, again, still follow the same formula here for the power rule. If you say here, x to the power negative 1, you do the derivative, which is negative 1 times x to the power negative 1 minus 1, okay? So far, this is easy. Now let's take a look at some question like this. We will learn about the product rule. What will happen if you have two guys times together? You want to do it a derivative. How do we do that? U times v prime equals to u prime times v plus u times v prime, okay? You might not know why this is true. We are going to use the definition of derivative to show the formula over here, okay? Let me call a student to work with me together. Aiden, go ahead, unmute yourself, please.
Oh, hello?
Yes. We have u times v. We want to do u times v product derivative. Based on the definition, we can say this equals h approach 0, and then u of x plus h times v of x plus h minus u times v. What can we do next?
I think you expand, right?
Yes. So we copy down this, and what we should write down here?
It's just distributing it, right? So it's u times x plus h, and then you do times v times x plus h, and then you can do, I think this is wait.
We did some manipulations. We put this guy over here. We leave this minus ux times vx over here. But we did something here and something here. These two are exactly the same. Who is this guy? Anybody? Look, you can copy down this. You can copy down u of x plus h, and then you times of vx. Okay? And then here, you do u of x plus h times vx. Make sense?
Yeah.
Look here. This guy and this guy are the same. This guy and this guy are the same. Minus this plus this. They cancel each other, correct?
Yeah.
Okay. Now, we did these manipulations because when we see here, they have the same factor. We can take out this guy. U of x plus h. We put u of x plus h. And then times v of x plus h minus vx. And then divided by h. Okay?
Okay.
And for here, vx is a common factor. So I can take vx out. If I take vx out, my leftover is u of x plus h minus ux, correct?
Correct.
Now look at here. When h approach to 0, u of x plus h is going to be same as ux. When h approach 0, who is this guy? Aiden, who is this guy?
That's infinity, right?
No. That's the definition of v prime x.
Oh, right. Okay.
Does this guy come from here?
Yeah. Yeah.
You only change your f to v. So this thing, by the definition here, that guy is v prime x, correct?
Correct.
Now look at this. You have vx in common. So you take the vx out, and then you do ux plus h minus ux divided by h, correct?
Yeah.
Okay. Now, when h approaches to 0, who is this guy?
U prime x.
U prime x. Okay. So this is ux times v prime x plus vx times u prime x. This is called the product rule. This is called the product rule. Okay. So how do we apply this product rule? Let's give a try. Let's do one question over here. Yeah, I can make one example by myself. Okay. Let's see here. For example, fx equals to 3x to the power of 3 plus 1, and then times 2x squared plus x. Then let's go ahead, use the product rule we learned just now to figure out the f prime x. Go ahead. We want to do this guy derivative times this guy copy down, plus this guy copy down, times this guy derivative. Let's go ahead to it. Aiden?
Hello? Hello? Can you hear me?
Yeah, let's do this.
Okay.
This guy derivative
times 2x
times
squared plus x.
this guy copy down plus
And then 3x
this
cubed plus
guy
1
copy down
times
times this guy. Okay?
Yeah.
Let's continue. How much is here? How do we apply the power rule here? 3 is a coefficient, you copy down. You put 3 in front and then x to the power of 3 minus 1, right?
Yeah, and then you times, I think, 2.
And then you times this.
Yeah.
And then the other guy. This guy you copy down times who? This guy derivative
wait,
is
I
how
can't
much?
hear anything anymore.
Oh, really? Yeah, you can log
I'm
out.
back now. Sorry.
Okay. 2 times 2 is 4.
Yeah,
X to the power
x.
2 minus 1 is 1. And then x derivable is how much?
It's 1, right?
Yes, this guy derivative is 1 times x to the power 1 minus 1. Okay, this is 1. So that's 1. Now we'll continue next. 9 times x squared, 2x squared plus x plus 3x cubed plus 1 times 4x plus 1. Okay, and then you can times them individually. Let's do this. This is 18x to the power 4 plus 9x cubed plus this times this. That is 12x to the power 4 plus 3x cubed plus 4x plus 1. So that get 30 times x to the power 4 plus 12x cubed and then plus 4x and then plus 1. Okay, everybody has to be careful. The product derivative does not equals to this guy derivative times this guy. You can try. This guy derivative is 3 times 3, which is 9x squared. One derivative is 0 times 2x squared derivative is 4x, and then plus x derivative is 1. This guy does not equal this guy, okay? That is wrong. We have to watch out. When you have two guys product derivative, this equals to first guy derivative times the second one plus the first one times the second one derivative. I never ever teach you this guy equals to u prime times v prime. This is totally wrong, okay? Our formula is this. You do want to remember. Now, so far, any questions? Is there any question? No question? If no question, we are going to do the next harder question, which is a chain rule, okay? We will do product rule, chain rule, and quotient rule today. It is some part is very complicated. You want to focus here, okay? Be very careful. You have a composite function, f of gx. If you want to do this guy's derivative, you cannot just write down f prime of gx. You have to write down f prime of gx times g prime x, okay? So you have to do the outer layer and then do the derivative of the inner layer. So let's practice. Let's see how do we do this guy. Let me call student to work this with me together, okay? Olivia. Can you tell me how much is this? Let's do the binomial formula of Pascal triangle. How do we write down this? One, one, one. 2, 1, 1. 3, 3, 1, 1. Correct?
Yeah.
Okay, now go ahead. How do we write down this?
Wait.
How much does this guy equal? We want to expand this. Go ahead.
Is it
I cannot hear you.
2x?
Square to the power 3, right?
Yeah.
And then we write down the next one. And then, okay. And we have here 1, 3, 3, 1, correct?
Yes.
And this part, this guy times 1 to the power 0. This guy times 1 to the power of 1, 1 to the power 2, 1 to the power 3, and then plus all of them together, right? Okay. Olivia, continue. How much is this?
8x to the 6.
8x to the power 6 plus 2 squared is 4, right?
Yeah, so
3
12,
times.
12x to the 4.
Good. Plus
6x to the x squared.
that's it. Okay. Now, if we don't use this chain rule, we can expand this guy into here. Now, Olivia, go ahead. Use the power rule we have learned. Let's do the derivative. Go ahead. This guy derivative is
48x to the 5th power.
very good. Plus
48x to the 3rd power.
good. Plus
12x.
that's it, right?
Yeah.
Okay. We learned about this chain rule just now. Now let's see how do we apply the chain rule over here. Okay. A student always feel confused about the chain rule. Let's introduce another way of writing the derivative. Okay. Newton found out the derivative, write down like prime. That means the derivative. There's another famous mathematician called Leibniz. Leibniz designed another symbol because the derivative is the instantaneous slope. You have a curve like that, and then you have a tangent line there. So you are looking for the instantaneous slope, which is your derivative. Delta y over delta x is actually the derivative as long as delta x approach to 0. So they introduced this thing called dy over dx. Dy over dx means when delta x go to 0, delta y over delta x. Okay, so let's call the outlier. Let's call the outlier as y. The most outside function is y. And we use this whole thing called as u. This whole thing called as u. So y equals to u cubed. Y equals to u cubed. U itself equals to 2x squared plus 1. This is the u, okay? You want to get dy over dx. You want to get this composite function's derivative. You can represent this in 2 steps. You do dy over dx. That equals to dy over du times du over dx. Okay, a student have to be very careful here. The thing I teach you here are critically important. Right now we are only learning the calculus AP part yet. With the class continue going, we will learn the BC part. For the BC part, we will not just deal with the right angle coordinates. We will also learn the polar system, okay? And parametric functions and parametric equations. So at that time, those concepts are critically important. I want you to write down the notes here. The things I teach you here are critically important. Dy over du. Dy over du, Olivia, see here? If you want to do the derivative y related to u, you do the power rule here. That is 3u squared, correct?
Yes.
And then you are asked for dy over dx. We have dy over du, so we have to do a du over dx so that these two guys balanced. That's equals dy over dx. So we want to do a du over dx. This guy, du over dx, isn't that as 2 times 2 times x to the power 1. That makes sense?
Yes.
Okay, so the result is this, but we don't want to leave u, we want to leave x only. This is u squared, so we do this guy square, 2x plus 1 square. That's the first term square, which is the 4x to the power 4, plus double of this 2, which is 4x squared, plus 1 square, times 4x, correct?
Yes.
And then this is 16x to the power 5, plus 16x to the power 3, plus 4x. We times them individually. Look at here. Do they equal?
Yeah.
Okay. Do you like the chain rule?
Yeah.
Look at here, okay? This is to the power 3. And you may say, I like this way because I think this is easy for me. Oh, yeah, right. If you do this way, you can do it, no problem. If I change this to 30, can you still do this way? It's really complicated. You will keep writing all those numbers. You will continue writing all those numbers to the 30 layer, okay? Yeah, all the way down to the 30 layers. You will have trouble, okay? What will happen if this is negative? Then there's no way you can do that. So we have to use the chain rule. We have to use a chain rule. Sometimes the chain rule is really complicated. This guy is easy. It only have 2 layers. Layer 1, somebody to the power 3. Layer 2, 2x squared plus 1. This is the easiest chain rule application. In the homework, we will have way more complicated case, okay? Now, I want everybody to give a try using the chain rule, and the power rule to figure out this guy. Okay, go ahead. Everybody go ahead, do it on your paper, and then text me your answer. Start. You want to treat this as your first apple, and then you can do your own apple, okay? I want you to be able to figure out this question by using the information we learned here. Please find out this guy by using the chain rule we learned here. The outlier is somebody to the power of 1/3. The inner layer is this guy. We want to apply the chain rule. Is there any people who finished? Nobody? Emily. Let's do this together, okay?
Okay.
Look, the outside here, we can apply the power rule, correct?
Yes.
So if we want to apply to the power rule, we will drag this guy into the front and copy it down, okay?
Okay.
1/3. What I should write down next? Go ahead.
2x squared plus 1 multiplied by 2x squared plus 1.
Drag this into front. X to the power n. This guy go to n times x to the power n minus 1. Yes?
Yes.
So we copy down this whole thing as a package. And then we do this guy minus 1. 1/3 minus 1 is -2/3. Are you okay for here?
Yes.
Does this finish all the chain rule? Yes or no?
No.
So we need to times to who?
4x.
Very good, very good. We need to times the inner layer. The inner layer. Okay. So let's go to 1/3 2x squared plus 1 to the power -2/3 times 4x. This equals to 4x over this go to 4x divided by 3 times 2x squared plus 1 to the power of 2/3. Okay? Does this make sense to you now?
Yes.
Okay, thank you. Now, next one, we want to tell sine x. Who is sine x? Derivative, okay? How much is this guy? We start use the definition of derivative, okay? So here, sine, this is your fx. So fx plus h, that means sine x plus h minus sine x divided by h. I suppose students in this class has no trouble to writing down this formula. That's sine x times cosine h plus cosine x times sine h, and then minus sine x. Okay, now look at here. Sine x, sine x. So I will pull this guy to here. That gives me sine x times cosine h minus 1. Sine x times parenthesis cosine h minus 1 divided by h. and then plus cosine x times sine h over h, okay? In the first class, we learned about this guy many times. That equals to 1. This guy equals to 1. So we focus on how much is here, okay? Based on our current knowledge, we are not able to tell who is this guy, but there is always something called graphic way, okay? We can use the graphic to tell us. So that is saying we want to do cosine x minus 1 over x, okay? Cosine x minus 1 over x. Look at here. When x approach to 0, okay? Well, of course, this is undefined, but you are not looking for the function value. You are looking for the limits. So when you approach from the left and approach from the right, this function all go to 0. This function all go to 0. When you approach from the left or approach from the right, that guy always go to the 0. So this is 0. And this is 1. So this is cosine x. That's 0, that's 1. So that equals to cosine x. This guy go to cosine x. So sine x derivative is cosine x. I pause a little bit. Is there any questions? No question? Please text me. If you think the thing I teach here is a little bit hard, you text me hard. If you think I teach too fast, you say too fast. Give me comments. I do want everybody to understand here. Now, we want to say, if you have sine x derivative is equals to cosine x. Now I'm going to use the chain rule to see how much is cosine x derivative, okay? Lawrence.
Yes.
Cosine x, I'm asking you,
Mhm.
do you remember what's the formula? Cosine x and sine x are called cofunction. When we learned pre-cal, how do we convert cosine x to something that we use sine?
You can use cosine squared. Was it like square root of 1 minus sine squared?
That one is too complicated. We want to use the easy one. We want to use this guy, okay?
Okay.
Oh, these two are the same, right?
Oh yeah, here.
See here? If this is the x degree, if this is the x, that is pi over 2 minus x, right?
Right.
This is a, this is b, this is c. Cosine x equals to b over c, right?
Right.
Equals b over c.
Mhm.
And then sine of this angle is the opposite over the hypotenuse, so which is
Yeah.
also b over c.
All the
Okay,
same.
so this equal, all right?
Mhm.
Now, we want to rewrite this as here. Like that, right?
Right.
Okay. We know the sine derivative is cosine. So let's do the chain rule. This guy, as a package, you want to do the chain rule. Sine, you go to cosine, right?
Right. Sine will go to cosine. Yeah.
Yeah. So what we can do here is we do this, okay? We write this, we call u equals to pi over 2 minus x. Okay?
Okay.
So we want to do cosine x, or we want to do sine pi over 2 minus x. So basically the final function is like this, yes?
Right. Sine.
Does
Yeah,
it equal? Yes, this equal.
yeah, these are equal. Yeah, right.
Sine u derivative. That means what? That means
That means
sine u derivative is cosine u, right?
you. Yeah, right.
Cosine u. But u is not exactly same as x. So we want to do du over dx. Correct?
Yes, correct.
Now, this is cosine u. So we copy down cosine u, which is cosine pi over 2 minus x.
I have to
Who
write
is this guy derivative?
that derivative.
Constant derivative is 0.
That's 0. Mhm.
This guy derivative is how much?
That should be -1 only.
Thank you. Very good. Very good. That's beautiful. Good job. How much is this one here?
That one should it just be no. I'm not sure.
Look, cosine of this guy equals to A over C, right?
Right.
Cosine of this angle equals to A over C. A over C is opposite over hypotenuse. So that is sine x. Yes?
That is also sine x. Oh, I see.
This is also sine x.
Oh, I see.
So this equals to negative sine
Negative
x.
sine x.
Does this make sense to you now?
Yeah.
Okay, this is very important, okay? So we learned power rule, we learned chain rule, we learned product rule, and we also know sine x derivative is cosine x, and the cosine x derivative is negative sine x. So far, any question? Students, don't feel embarrassed if you think you ask some question which are not very smart. Any question are good question, okay? If you don't ask me question, doesn't mean that you understand everything. I'm sure you students have a lot of question here. If you don't ask me question, I'm going to go to the hardest one, which is the quotient rule, okay? Are you ready? We are going to do the quotient rule.
Wait, teacher,
Yes,
can you scroll down a bit to like
Okay.
the problem which is in the brackets and it's 2x squared plus 1 to the power of 1 over power 1/3.
there.
Yeah.
Okay.
Oh yeah, I'm good now. Thank you.
Sure. Now let's see. Next. I want everybody to truly understand the product rule and the chain rule. Now we are going to do the quotient rule, okay? Quotient rule. When you have a u divided by v derivative, this guy, we want to rewrite this u over v equals to u times v to the power of -1. We rewrite this. After we rewrite this, the quotient format change to the product format. So let me call student to work with me together, okay? Any volunteer? No volunteer? Angela. Let's go ahead to this guy.
Okay.
How do I use product rule?
So you like simplify it out, and then it becomes u prime times b to the power -1 plus u times b to the -1 prime.
Okay. As the product rule here, this guy prime times this guy copy down plus this guy copy down times this guy prime. Okay. Let's do This is just u prime over v, okay?
Yeah.
The other guy, this is u times. How do we do this one? We have to use a chain rule, okay? The out layer is this guy. The inner layer is a v. Go ahead, tell me this equals how much?
Do you do like -1 times v to negative power 2?
So you do -1,
Power
-1 times
times v to the power -2.
-1 minus 1. That's a power rule. And then because the v is not x itself, we have to think about v itself is also a function. So you do v prime.
Yeah.
Correct? V prime. This is critically important. You cannot ignore this part. If you ignore that part, that's wrong. Because the chain rule said out layer is a power rule. Inner layer is a function of x, so you have to do v prime, okay?
Okay.
Now, let's continue. Next. We can do one more step. Go ahead. What's the next step? So I will write down u prime over v minus u over v squared, right?
Yeah.
Times v prime. Let's do a common denominator, okay?
Okay.
Let's change everything to be the same common denominator. How much is the denominator?
V.
V squared, correct?
Oh yeah.
V squared. So that guy becomes to
U prime times v.
u prime times v, and then minus
U times v prime.
All right. Okay. Very good. So the quotient rule, even though this looks a little bit complicated, but actually it is not too hard to remember. The trick of remember this is you treat this similar as a product rule. This guy, product rule is u times v prime plus v times u prime. What do you do here? You do u prime times v, and you minus u times v prime divided by v squared, okay? Divided by v squared. Does this make sense? Now we are going to apply this quotient rule to do the trigonometry function derivative. Is there any question for this formula? No question? Students, if you ask more, you understand even better. If no question, we are going to use this to do the following formulas, okay? Look at here. I put the quotient rule over here. U over V derivative equals U prime times V minus U times V prime over V squared. Now we already know the sine X derivative is cosine X. Cosine X derivative is negative sine X. Now we want to do tangent X. Tangent X equals to sine X over cosine X. Look at here. This is your U. This is your V. We are going to do the quotient rule, okay? Let me call student to work with me together. Any volunteer? Seriously? No volunteer?
I can do it.
Okay, let's do.
Okay, so from the quotient rule, it's sine x prime times cosine x minus sine x times cosine x prime over cosine squared x.
Sine x prime times cosine x minus sine x times cosine x prime over
Cosine squared x.
good. equals.
You know sine x prime is cosine x, and you know cosine x prime is negative sine x, so it becomes cosine squared x plus sine squared x over cosine squared
This
x.
is minus sine x times cosine x prime is negative sine x.
Yeah,
Negative sine x times negative sine x is positive sine squared x. Okay,
right.
and then divided by cosine squared x. How much is this?
That's 1.
Very good. Trigonometry identities. That equals to 1 over cosine squared x. Who is 1 over cosine x?
Secant x.
Secant x. So this becomes to secant squared x.
Right.
Okay, this becomes secant squared x. Students, if you have trouble to remember all those formulas, let me know. I can send you the pre-calculus notes, okay? In pre-calculus, there are critically important formulas which are very necessary for learning calculus. If you have trouble remember that, then you might have big trouble for learning calculus. So all my formulas here, I have, okay, these are the 30 important formulas, okay? All the students who learn pre-cal with me have no problem to remember all of this formula very quickly, no problem. If you have trouble, I send you these notes. You can take time to remember this. Now let's come back. So tangent x derivative equals to secant x. Now everybody go ahead, use this as your first apple. Do your own apple to figure out cotangent x derivative. Go ahead, everybody do it. Do this one now. Any volunteer?
I can volunteer.
Okay, let's do it.
Okay, so use the quotient rule. So you do cosine x prime times sine x minus sine x prime times cosine x divided by sine squared x.
Okay, which is applying this formula. Next step.
Okay, and then so you know that cosine x prime is negative sine x, so it becomes negative sine squared x minus cosine squared x. And that's also divided by sine squared x. And you can take out the negative 1, so it's negative 1 because sine squared x plus cosine squared x is 1.
That's good.
You get negative 1 over sine squared x, which is negative cosecant squared x.
Yeah, that's a perfect one. Very good. Okay. Is there any questions? Other student, can you get this step by yourself? Everybody, this is those formula you have to remember. Why? Because in the quiz test, they don't provide you this list. You have to know this by yourself. And this will be important foundation for our next several classes, because trigonometry derivative will be the foundation for the inverse trigonometry derivative, okay? And you learned sine inverse or arc sine x derivative. Thank you. If you can do this by yourself, text me, okay? I know that Lawrence can do this by himself. We want to make sure everything we learn here, you can do this by yourself, because we will learn arc sine x derivative, arc cosine x derivative, arc tangent, arc cotangent, arc secant, arc cosecant, okay, derivative. That formula are really important. If we cannot do here well, we are not able to do the inverse trigonometry derivative well. If we are not able to do the derivative well, then when we learn the calculus for the integration part, it's even more complicated. Everything will become impossible, okay? I need everybody, you have to. It's not like you want it or not. You have to know all of this. Product rule, chain rule, quotient rule, power rule, sine x, cosine x, tangent, cotangent. And next we will do the secant and cosecant. Secant x. Any volunteer who want to do the secant x derivative with me together? Any volunteer? Any other students? Lawrence, let's go ahead.
Okay. You can write it as 1 over cosine first. We can rewrite
Good.
that. And that, yeah. And equals,
We can do the power rule. We can do the chain rule. Let's do this way, okay? Look,
okay.
cosine x to the power of -1. And
Okay.
then this. The outlier is the power rule.
Power, right.
We do -1.
You 1. And that's cosine x to the power of -2, I think.
Yes, that's beautiful. Times.
Times I had to do the inside, so cosine. Oh, sorry. Yeah, so it would just
Cosine
be
x
1 then.
prime. Cosine x prime. Yeah.
Cosine x prime. Oh, yeah, right.
Who is this guy?
And we scroll back up, but I don't think we're gonna. We scroll back up. We already done it. Negative sine x.
Good. You made it. This equals to -1 over cosine square x times
Right.
negative
Negative sine x.
sine x.
Right.
This becomes to sine x over cosine square x.
Oh, I see.
Okay.
Okay.
Right.
Right.
Look.
And then,
It's not. How much is this guy?
that equals tangent.
How much is this guy? One over cosine x.
1 over cosine x, right?
And
And
is
also
secant x.
secant x, right?
So this equals to tangent x times secant x. Does that make sense?
Yes, makes sense.
Okay, very good, Lawrence. That's awesome. Very good. So I believe Lawrence, Aiden, and Angela, they can handle this kind of question. Any other volunteer? Any other student who can do like Lawrence, Aiden, and Angela? Who else? Who else want to try? I'm not a mean teacher, okay? If you stuck, I will walk through with you. If you answer the question, you get the chance to improve yourself. Any volunteer who want to do this with me together? This is similar to this. Nobody?
I can do it.
Cindy, right?
Yeah.
Let's do it.
Yeah. So I'm pretty sure it's just 1 over sine x.
Good.
The prime 1 over sine x, and then like similar, very similar to the other problem where it's like inverse sine x.
Mhm.
And then it's just and then you follow like the formula from before, like n times something n minus 1 to the power of n minus
-1 to the power of sine x to the power of -1 minus 1 -2. And
So
then
it's-
times what I read here,
sine x.
right? Okay. Continue.
Yeah, and then I think that's equal to -1 over sine squared x. Because like if you define
Mhm.
and then times negative sine x. So
Okay. Who is this guy derivative?
oh negative
No.
oh no, it's just cosine x.
Yes. Thank you.
Wait, prime cosine x is negative sine x, right?
This guy is 1 over sine square x. This
Yeah.
guy derivative is cosine x. Sine x derivative is the positive cosine x. Cosine x derivative is negative sine x. Okay. Now let's rewrite this. That equals to -1 over sine x times cosine x over sine x. Okay.
Yeah, so negative cosecant x times cotangent x.
That's it.
Mhm.
All right. Now I'm going to leave this page for several seconds. You can go ahead and finish your notes and we will do the applications. If you finish write down everything, you can tell me, okay? Everybody finish copy down? Now let's do the questions. This is a homework for today, okay? That guy, this is easy. Doing this guy derivative, you do 9 over 4 times x to the power 9 over 4 minus 1. Okay, too easy. This one, -5 times -7 over 3 times x to the power -7 over 3 minus 1. Too easy. So this, if the question is too easy, I will skip, okay? And this one, you do this guy derivative minus that guy derivative. If it has a coefficient in front, you just copy down. Okay, so number 3 is too easy. Number 4, too easy. Number 5, chain rule. Let me call number 5 is still too easy. Let's do number 6. Student, any volunteer who want to do the number 6 with me together? Anybody? Nobody? Clear. Let's do number 6 together. Clear.
Okay.
Look, this is using the chain rule. The alt layer is that guy, right? Yes.
Yeah.
So we copy down -68. Yes. We copy down -68 in front. Yes.
Yes.
And then to the power of this guy times this guy, copy down to the power of -68 minus 1, right? Correct?
Yes.
But the inside here is not just the x. This guy is also a function. So we have to do the chain rule. We want to do this guy prime, yes?
Mm-hmm.
This guy prime. That becomes -68 times 12x cubed minus 3x plus 4 to the power -69 times 12 times 3, which is 36, and then x squared minus 3x derivative is how much? Derivative is how much?
That'd be just 3.
Okay, and then plus 0. 4 is a constant. Constant derivative is 0, okay?
Mm-hmm.
All right. Now, that's number 6. Claire, do you have any other question for here? No question. So number 6 is also very easy, okay? Now let's take a look at number 7. Yeah. I don't like easy question, okay? When the question becomes complicated, I feel very happy. Let's do number 7. The easy questions are too boring, okay? I want to do the challenge questions. Number 7, who want to do this with me together? Who want to try?
I can try.
Let's try number 7.
So,
Okay, look at here.
mhm. So
There are outside is a power, inside is a quotient, right?
Mhm.
Okay. So f prime x equals
3 times x minus 1 over x plus 1 squared, maybe.
times. You take care of this layer, and then you want to do the quotient rule for the inner layer, okay?
Mhm.
Let's do the quotient rule for this guy. Go ahead.
Mhm. Okay, x, wait, derivative of x minus 1 times x, I don't,
This guy derivative, which is x minus 1 prime times,
times x plus 1,
okay, minus,
x, blah, minus x minus 1 times derivative on x plus 1
okay,
over x plus 1 squared, I think.
that's right. This is awesome. Very good job, Cindy. This is good. I like it. Now, this guy, what's the result? How much is this?
I think this is just going to be 1.
Yes.
Yeah.
This x derivative is 1. Constant 1 derivative is 0. So this guy equals to 1.
Yeah.
This guy is 1.
Mhm.
How much is this guy?
I think that's 1 as well.
Yes. Yeah, I don't want to write down this look like 1. We want to call this as a prime. This guy is 1. Okay. So let's write down the next layer. One times x plus 1 is x plus 1. And then minus 1 times x minus 1 is x minus 1. And divided by x plus 1 squared. Okay. Now, how much is this?
That's just 2.
Yeah, that's just 2. So 2 times 3 is 6. And then divided by the denominator becomes,
X plus 1 to the power of 3.
really?
Wait, hold up. Oh, wait, no. X plus 1 times x squared plus 2x plus 1.
Here is x plus 1 squared. And then times another x plus 1 squared, which is?
X plus 1 to the power of 4. Sorry.
Okay.
Yeah.
Okay. Sometimes I also make a careless mistake. Okay. Well, that's number 7. Let's look for those beautiful questions. Okay. Is this beautiful? I don't think it's hard enough. This is easy. This is to the power 1/2. So if you want to do this, power rule and the chain rule, 1/2 times 3x plus 1 to the power of 1/2 minus 1 is negative 1/2. And then 3x plus 1 derivative is 3. Okay, so this question is easy. I don't want to write down this. Is number 9 hard enough? It is an okay question. Okay, it's not hard. Let's do number 9. Volunteer. Any volunteer? Then go do quickly so that I'm able to finish all those hardest questions, okay? Anybody? Emily, yeah, we can rewrite this first. Okay,
Okay.
now you can treat this as a product rule, okay?
Okay.
Go ahead.
Do I take 1/2 to the front first?
Let's do this guy derivative times this guy copy down plus this guy times this guy derivative, okay?
Okay.
So you do x
plus
prime times the other guy plus x you copy down and times that guy. Who is this guy derivative?
1/2 multiplied by 2 minus 7x squared. 1/2 minus 1.
Very good. and then times
and times 2 minus 7x squared.
prime, right?
Yes,
Okay, that's a chain rule, yes?
yes,
Okay. X prime is how much? Is 1, right?
yes.
This guy equals to 1. So this is plus, this is 1/2 x times 2 minus 7x squared to the power negative 1/2. How much is this? That's 0, yes?
Oh,
Any
yeah.
constant value, do the prime, go to 0. How much is this guy derivative? How much?
Is it still 0?
And no, you do the power rule. This guy derivative is 0. This guy is negative 7 times 2 times x to the power 2 minus 1. Okay.
Okay.
Negative 7 times 2 times x to the power 1. All right. Does this make sense now?
Yes.
So this is square root of 2 minus 7x squared. And then this 2 and this canceled, right?
Yes.
This canceled. So that means you have minus 7x squared over square root of 2 minus 7x squared. Okay?
Okay.
All right, that's number 9. Are you cleared for this question now, Emily? Now let's do, does 10 looks complicated? Might be. Let's try number 10. Any volunteer? Nobody?
I can try, maybe.
Okay, thank you. Let's go ahead. We can write down this first as
X power of 1/2, and then that to the power 1/2. Yeah.
yes. So f prime x equals
Equal, you have to prime the first one, the 1/2, the entire thing first. 1/2, right? And then 4x minus x to the power 1/2. And then you do 1/2 minus 1 to the power. That's in the power. That would be a -1, yeah. And then you got to do it inside, so you multiply 4x, so you can just write just 4, I think, minus, I think it's just 1/2 to the power of -1, or 1/2 x times, or to the power of -1/2.
that's beautiful. Very good. I think you mastered the skill now. That's it, right? Yes.
Yeah.
We do the power rule first, and
Yeah.
then we do this whole thing derivable.
Yeah.
Derivative. I think it stopped here. Oh, that's good.
Oh, okay.
And then we do here, which is 1/2 divided by 1 over 4x minus square root x, and then times 4 minus 1/2, and then square root x put on the denominator. That's it. Okay, very good, Lawrence. Nice. This is really nice. Yeah, I think in one class you already mastered all those rules. Okay, product rule, quotient rule, chain rule, which is good. Let's see. This guy is easy. You do this guy derivative, that is cosine phi x. not finished. You want to times phi x prime. Phi x prime is phi. So the answer is phi times cosine phi x. Okay, easy question. This one you do here. 3, you copy down. You do 3 times cosine of this. That means negative of sine pi x squared. And then you want to do this guy derivative, which is pi times 2 times x to the power 2 minus 1, which is 1. That's the answer. Okay. Now you have the video, so you can see every question, all the hard question details. So that is easy. How about number 13? This one. You can do this. This go to 4 times sine cube x. And then sine x, you have to do the sine x derivative, which is cosine x. And then you plus 4 times cosine x to the power 4 minus 1, so cosine cube x, and then times cosine x derivative is negative sine x. So you have result like this, okay? And don't forget, sine x and cosine x are not x. You have to do their sine x derivative, which is this, and cosine x derivative, which is this, okay? So you want to watch out for question 13. For question 14, that's this. How do you do the derivative? Negative 3 times cosine x to the power negative 3 minus 1, negative 4. And then times cosine x derivative is negative sine x. Okay, that's it. That's for number 14. Now, number 15. Any volunteer? No volunteer? Olivia. Let's do number 15.
Okay. So the
You do this guy, yeah? This is to the power of 6. So what you do? You copy down 6.
times tangent x to the 5th.
So you put 5 here, okay? And then, yeah, as student, you have to know this, okay? Tangent, if you have here, that means you do tangent x first, and then you do the to the power 6. This means the same thing. But watch out. If you have something like this, this means you do the x cubed to the power 6 first, and then you do the tangent. These two are the same. These two are the same, but they are totally not equal, okay? This and this are totally different. So you put 5 here. Olivia, what do you want to write down here?
Secant
Tangent derivative is how much?
is it secant square x?
That's right. Very good. Secant square x. Okay, very nice. Well, number 16 and the number 15 are similar. You can handle it. Look at here. Volunteer? Any volunteer? No volunteer? Aiden. How do we do this?
Okay, you make it to the power of 1/3 first.
Sure. So?
You take the derivative back, so you do, it's 1/3 times 1 minus sine x to the power of 1/3 minus 1. And and then you multiply that by the derivative of 1 minus sine x.
Hey, hold on. This is power rule, and then we do the chain rule. We do this guy, prime, yes?
Yeah, prime sine.
1 prime is 0. Negative sine x prime is how much?
That's negative cosine x.
Yes, this guy prime is 0. Negative sine x prime is negative cosine x.
Yeah.
So times negative cosine x, okay? Now, number 18 is not hard. Let's take a look at number 19. Sine inside cosine. Let's watch out here, okay? You want to do this guy a derivative. You want to treat this outlier first. Cosine of this package, derivative is sine, negative sine of this. So the outlier equals negative. A cosine derivative is negative sine, so this is negative sine, but your inner layer is sine x. And then you have to take care of this inner layer. This guy derivative is sine x, derivative is cosine x. Okay, that's it. That's the answer. Who want to try number 20 with me together? Volunteer? Nobody? Angela, let's do number 20.
Okay. Okay, so you have to find the derivative of tangent, which is secant squared x.
Yes, so we do tangent derivative is secant squared, right?
Yeah. So then it's
And-
secant squared, and then because secant is still inside of it.
Yeah, you put this guy inside, right?
Mm-hmm. And then
And
the secant derivative, which
who
is
is this guy?
negative cotangent x
Times
cosecant x.
cosecant derivative is negative cotangent times cosecant, right?
Yeah.
Okay. Okay. So we first treat this layer, we do the secant of this, secant square of this, and then we do that guy derivative, which is negative cotangent times sorry, here I have a typo. Negative cotangent x times cosecant, okay? Okay. Let's see if there are any other harder questions. This is using chain rule. You treat this to the power of 1/2. And then you do the power rule first, and then you do the inside. This one, you can do the quotient rule, not a problem. This one, you can do the quotient rule. You can also do the product rule. So what you do here, you change this to x to the power of -1 times 5 minus 2x to the power of -1/2, okay? And then you can do the product rule. You do this guy derivative times this guy plus this guy times this guy derivative, okay? This is possible, not hard. How about this one? You say, teacher, I think this can be canceled. No, this cannot be canceled, okay? This cannot be simplified. You can just use a quotient rule. You go to the guys here to the power 2, this whole thing. And this guy derivative times this guy, and then minus this guy times this guy derivative, okay? So this question is okay. This one, you can do the product rule, okay? You do x derivative is 1. So you do 1 times cosine 1 over x plus x times this guy derivative. This guy derivative is negative. Cosine derivative is negative sine of that guy. But is this finished? No, because you haven't taken care the 1 over x yet. This guy times this guy derivative, which is negative sine of the whole package here. You have this guy here. It is not x, it's 1 over x. So you times change rule. 1 over x derivative is negative 1 over x squared. Okay, so that's the answer for number 25. Is there any questions? Now the last one is 26. F prime x. I do the product rule. X squared derivative equals to 2x. Copy down. Plus this guy derivative is 2x. This guy copy down. And then this guy copy down. And then this guy derivative. This guy derivative. Second derivative is tangent times secant. So tangent times secant. Is this finished? No, you only finish up to this layer. You haven't done this inner layer yet. Who is this guy derivative? 1 over x to the power 3 is x to the power negative 3. That guy derivative is negative 3 times x to the power negative 3 minus 1. Okay, so the final answer is here. Everybody, for all the 26 questions in the homework, you have to make sure, don't look at my answer, do by yourself. You have to be able to do every single question by yourself after class, okay? If you feel the question here is kind of hard, that means you have to work hard. Next class will be even harder, okay? You want to work as hard as possible because all the following class will be even harder. AP class is not going to be easy. The notes I show you here, you are supposed to be able to derive the product rule, the quotient rule, the chain rule, sine, cosine, tangent, cotangent, secant, cosecant. You are supposed to know all of this by yourself, okay? For this page question, we will leave it to the following class. You are welcome to take a look if you are able, see if you can handle this question by yourself. Those 7 questions are beyond this week class. We can talk about this in the further class, okay? Is there any questions? Understand everything I show you, I teach you in the class. If you have trouble, check out my videos and then finish the 26 question all by yourself. If you get stuck, check my videos and my notes, okay? That's for today's class. I will upload the video and I'll see you next week, okay? Bye-bye.